This question is a little different than the ones that we've previously encountered. We're still being asked to find the minima and maxima for a particular function, but you'll notice in this case we've been given a closed interval. We've been told that for this particular quartic function we are going to try to identify minimas and maximas for x values between and including -1 and +4. So in this particular case, we're going to have to consider endpoints, which we haven't done in the previous questions. Well, we start by taking our derivative, j prime of x, which is equal to 12x cubed minus 48x squared plus 36x. And we set that derivative equal to 0. And we solve the resulting cubic. We first start by dividing everything by 12, because everything is divisible by 12. Then we common factor an x out, and then the resulting quadratic can be factored further by inspection. So we end up with 0 equals x times x minus 3 times x minus 1. So that produces three values for x. It gives me x value is equal to 0, x is equal to 3, and x is equal to 1. Then we must find the corresponding y coordinates. And the corresponding y coordinates, when x is equal to 0, the corresponding y coordinate is 0. When x is equal to 3, y is equal to -27. When x is equal to 1, y is equal to 5. Those corresponding y coordinates were found by using the original function, j of x. So what we now know is that we have three critical points, 0, 0, 3, -27, and 1, 5. Now what we also have to consider are the endpoints, because we were given a closed interval. We knew that we have an endpoint at x equals -1 and x equals +4. So we need to find the corresponding y coordinates. Again, we'd be using the original function j of x to do so. We find that when x is equal to -1, y is equal to 37, and when x is equal to 4, y is equal to 32. So now what I've done is, with the assistance of my graphics calculator, is I've graphed this particular function, and you'll notice that I'm going to indicate that it does have endpoints. I'm not going to put little arrows at the end of this particular quartic function because it doesn't extend on forever and ever. Well, I first start by labeling my critical points. My first critical point was at 0, 0, so I label that one. The next one was at 1, 5, and then the third critical point was at 3, -27. Then what I've done using the green marker, I've also boxed in the endpoints. So that first endpoint that I've boxed in is -1, 37, and the other endpoint is 4, 32. So when we look at this, you'll note that we have an absolute maximum at the endpoint -1, 37. We have an absolute minimum at the critical point 3, -27. We have a local maximum at 1, 5, which was a critical point. We have a local minimum at the critical point 0, 0. Now, some people would argue that there is also a local maximum at 4, 32. That's according to the textbook that you're presently using. And you'll see in the various answers that I supply with for the homework sheets that I'll often say that this is considered to be a local maximum based on Finney et al., making reference directly to the textbook. But you'll find other textbooks that indicate that endpoints cannot be local minimums or maximums, that they can be absolute maximums or absolute minimums, but not local maximums or minimums. And that's the definition I tend to use, and you'll probably find that most of your professors at university use that definition. So it is a little area of confusion, and you'll have to decide what technique your professor at university wants you to use. But for now, I'm going to just indicate with this particular question that we have only one absolute maximum, one absolute minimum, one local maximum, and one local minimum.